Hi, hello everyone. Today our chapter is acids, bases and salts. In this, we are going to know about what are acids, properties of acids, what are bases, properties of bases, what are indicators and types of indicators and its properties. First, we'll know what are acids. An acid is a substance that produces hydrogen ions when placed in water. See, when acid is placed in water, it produces hydrogen. Okay. When acids or ionic compounds are dissolved in water, the ion splits apart from each other. See, in this example, if you see the hydrogen chloride getting splits into chloride separately and hydrogen separately. This is what happens. Okay, now we know the properties of acids. See, most acids, they taste sour. Okay, and they react with many metals to form H2 gas. And they turn blue litmus solution red. They give H plus ions in aqueous solution. The pH is less than 7. About pH we will study in the next part. Now you just know acids have pH level less than 7. Okay. Now in acids there are strong acids, weak acids, concentrated acids and dilute acids. There are strong acids like HCl, H2SO4, HNO3, that is hydrochloric acid, sulfuric acid, nitric acid. Then weak acids are CH3COOH, oxalic acid, lactic acid. Okay, next concentrated acids are more amount of acid plus less amount of water. If this combination is there, then that is concentrated acid. Then dilute acid is here there is a more amount of water, less amount of acid. Okay, concentrated means there the more amount of acid will be there. In dilute acid, more amount of water will be there. Okay. Next, there are some common acids. What are those? Citric acid, lactic acid, acetic acid, carbonic acid and hydrochloric acid. Citric acid is found in citrus fruits and we use that as a preservative. Citric acid is used as a preservative. Then lactic acid is found in yogurt. This is produced by our muscles when they are overworked. Then acetic acid, they are found in vinegar, that is also used as a preservative. Then comes carbonic acid or phosphoric acid. Okay, these are found in soft drinks. Then hydrochloric acid, these are found in our stomach, aids in food digestion. Okay, hydrochloric acid is present in the stomach walls which helps in a digestion. Okay, now bases. A base is a substance that produces hydroxide ions when placed in a water. See, we have learnt in acids they give H plus ions when placed in water. But here in bases, when placed in water, they give OH minus ions. OH minus is hydroxide ions. Okay, when placed in water, these base compounds are dissolved in water. The ion splits apart from each other. This splitting is known as dissociation reaction. Okay, here if you see there is an example, that is sodium and hydroxide. They are splitting up into sodium and hydroxide ions. Okay, see this splitting up of ions is known as dissociation reaction, where one reactant is splitting up into two or more substances. This reaction is a chemical dissociation reaction. Okay, next comes properties of bases. See, most bases taste bitter. They are bitter in taste and they feel slippery. They turn red litmus solution as blue and they give OH minus ions in a aqueous solution and the pH is greater than 7. If their pH level is greater than 7, then that solution is known as bases. If the pH level is lesser than 7, then that solution is acid. Okay. Now in this bases also there are strong bases, weak bases, alkalis. Strong bases like NaOH, KOH, CaOH twice. That is sodium hydroxide, potassium hydroxide and calcium hydroxide. Weak base like NH4OH, that is ammonium hydroxide. Okay. Next, alkalis. These are bases which are soluble in water. These bases are totally soluble in water. Example, sodium hydroxide, potassium hydroxide and calcium hydroxide. Okay. Next, there are some common bases like ammonia. They are used in cleaners and fertilizers. We use in cleaners and fertilizers. Then there is sodium hydroxide. Sodium hydroxide is used in soaps and drain cleaners. Okay, then magnesium hydroxide, an ingredient found in antacids. So these are all the common bases. Okay. Indicators. What is indicators? Indicators are used to determine if a substance is either acid or a base. Okay. An indicator changes a specific color when in the presence of an acid or a base. See, if we add indicator to an acid, that will give a specific color. If we add an indicator to a base, that will give a specific color. So, using an indicator, we can find out the substance is whether acid or a base. Okay. Now, there are types of indicators also. There are many types of indicators. Some common we will know here. First one is natural indicators. See, the name only suggests the indicators obtained from the natural sources are known as natural indicators. Like litmus, turmeric, red cabbage, China rose, etc. These are some common natural indicators. Okay. First, we will know about litmus. Litmus is obtained from lichens. Okay. The solution of litmus is purple in color. The solution is purple in color. Litmus paper comes in two colors, that is blue and red. Okay. If an acid turns blue litmus paper to red, if the solution is acid, the litmus paper turns from blue to red. Okay. If the solution is base, the base turns red litmus blue. Okay. Now, turmeric. Turmeric is another natural indicator. Turmeric is yellow in color. Turmeric solution or paper turns reddish brown with base. See, turmeric reacts with base and it turns the color into reddish brown. Okay. Turmeric does not change color with acid. If the substance is acid, there will be no color change. If the substance is base, there is a color change to reddish brown. Okay. Next, red cabbage. The juice of the red cabbage is originally purple in color. Juice of red cabbage turns reddish with acid and turns greenish with base. See, if the substance is base, that will turn into greenish color. If the substance is acid, that will turn into reddish color. Okay. Next, olfactory indicators. See, the substances which change their smell when mixed with acid or base. See, here there is no color change. There is a sensation of smell. Okay. This is known as olfactory indicators. For example, onion, vanilla, etc. See, first we will know about onion. Onion. Paste or juice of onion loses its smell when added to base. See, if we add the paste of onion to a base, there will be no smell. Okay. It does not change its smell with acid. If see, onion will not change smell with acid. If it is a base, there is a change or it loses its smell. Okay. Next, vanilla. The smell of vanilla vanishes with base. There will be no smell of vanilla if it is a base substance. But its smell does not vanish with an acid. If the substance is acid, there is no vanishing of the smell of vanilla. Okay. Olfactory indicators are used to ensure the participation of visually impaired students in the laboratory. See, there are some students who cannot see. Okay, at that time, if in other indicators you see the color change. See, they don't have the power to see, so they can feel the smell. So, for this olfactory indicators are specially used for them, like visually impaired students. Okay. Next, synthetic indicator. Synthetic, as the name only suggests, these are man-made indicators. Indicators that are synthesized in the laboratory are known as synthetic indicators. For example, phenolphthalein and methyl orange. Okay, first phenolphthalein. It is a colorless liquid. There is no color for this indicator. It remains colorless with acid. If phenolphthalein is added to acid, there is no color change. And if you add it to a base, that turns into a pink color. The solution or substance turns into a pink color. Okay. Then methyl orange. Methyl orange is originally orange in color, but it turns into the red with acid. When methyl orange is added to acid, there is a color change into a red. Okay, if you add it to a base, there is a color change to a yellow. So this is also a color change process. Okay. Next, thank you.